So, could you talk a little bit about energy and hold on. The like momentum flux density and then the energy density of waves?
Oh yeah, Maxwell stress tensor we never covered.
With respect to
The Maxwell stress
Tensor we never covered.
yeah, okay. Actually, I figured that the stress tensor itself is very well defined,
Yes.
It was.
and that I would just force you to read about it. So find all the elements of Maxwell's stress tensor for a monochromatic plane wave traveling plus z direction, linearly polarized in the x direction.
Yeah, that wasn't.
Compare the momentum flux density to the energy density in the wave.
All one of them.
So getting the tensor is
Getting the tensor is easy.
yeah.
So-
what do you do with it? Like,
The-
what does it mean?
No, the name momentum flux density refers to the Maxwell stress tensor itself, and then the energy flux density is T00 in the
Times C.
Maybe there's a C in there.
This is a lot more useful.
Well,
Right.
So you think you've got momentum,
Right.
right? And for a photon, in order to turn momentum into energy,
Yes.
you multiply it by the speed of light.
Okay.
So if you have the momentum flux density, you can turn it into an energy
So
flux.
is this? So how do you get? How is the momentum flux density related to the Maxwell stress tensor?
I think it's the 0, 0 term. I'm not positive.
the momentum flux of Maxwell stress tensor is the diagonal of Maxwell stress. The T00 is the energy.
Oh, that's the energy. Okay, first term is the energy.
He has a diagram in the book
Over C.
where he draws it out.
Yeah. I'm going to leave it to you.
Alright. I didn't know it was actually in the book.
What page?
275.
There we go.
Yeah.
So, what do I actually, I want to say something, let's say, about that, why I give so little attention. Which is that I've actually never used the Maxwell stress tensor in my professional life. And I do optics. However, Professor Napolitano thinks that it's something that you should know about. So I decided that, well, okay, I'll just give you one homework problem that relates to it, so that I force you to go back and read that chapter of the book.
Okay.
That little section of the chapter in the book, so that you don't come out of this course not having ever seen it.
Okay.
But again, it's possible that particle physicists use it, but I know that condensed matter physicists never use it.
The relevant picture is 278, where he
Page
tells you
278. Yeah,
where he tells you what it means.
Okay.
So since I don't ever use it, I forget which term is which.
Right.
You know, I don't care.
Um,
I care enough about you to assign you a problem on it,
oh. Thank you, Sam.
but not enough about the Maxwell stress tensor to actually read the chapter again.
Okay. And so I just want to get this, make sure I have.
You'll
it
have
right.
your chance at it.
I want to make sure that I have this right in my head. The Poynting vector is energy per unit area per unit time. It's energy
Yes.
flux per unit time.
It's power
Yes.
per meter.
Pointing vector is power per area,
Okay.
energy per unit area per unit time. And then you have to average the Poynting vector to find the total
Flux.
Yeah, that's right.
the average
Yeah,
energy.
that makes sense.
Your average Poynting vector, which gives you a 1/2
Right.
when you have a wave.
Minus
Okay.
9 omega t.
All right.
Yeah, this is
It's
very
luminosity actually.
Adam,
Luminosity.
What do they mean by, in question 59, plate waves, or what is it called, 2 quarter wave plates? polarizers?
No. In the notes, did I post the notes?
Yes.
Yes.
I did, okay. In the notes, I have a thing that's called a quarter wave retarder.
Okay.
A quarter wave plate is a quarter wave retarder.
Oh, okay. And then the product of two is just the Pop matrix multiplication.
Yeah, if the two retarders are on the same axis, then it's a half-wave plate.
Oh, okay.
But if they're rotated with respect, one might have the fast axis this way, and the other one would have their fast axis this way,
Okay.
then it does nothing,
Okay. I was just
except delay the whole way.
Yeah, I was just wondering about the waves of that.
Wait a
Yeah.
second.
There's a
So
nice
what is the fast? So the fast
table
axis is
on
the axis.
the Wikipedia page for Jones calculus.
Yeah, no, I don't know.
Okay, the fast axis is the axis with the phase of the wave advanced. And when we say a quarter wave, the phase of the wave after it's passed through the wave plate is 1/4 wave advanced on the fast axis with respect to the other axis, right, perpendicular axis.
So does that mean that there's one wave plate that's 30 degrees to the other, or is the light coming in at 30 degrees to the fast axis?
Let me read the sentence that I wrote, and then I will try to make sense of it. At the time that I wrote it, I thought it made perfect sense.
Makes sense.
Makes sense. You just have to rotate the.
Oh, yeah, okay. A half-wave plate can be represented by the product of two quarter-wave plates,
Yep.
oriented in the same, fast axis in the same direction.
Is that?
Yeah. Okay,
Are the
so,
fast axes in the same
so
direction?
it would be something like 1, 0, 0, I, and 1, 0, 0, I.
Right.
Would be
Got that.
two oriented in the same direction.
There's a theme.
Did I mess that up or what?
No, as far as I know, it's good.
Okay, so you just do the product.
Yes, there is.
You ignore the factor up front.
Well, you can include it if you want.
And what you'll end up with is linearly polarized light.
The other one.
Sorry, a linear polarized is what you'll end up with.
20 vector was 10.
Okay? At 45 degrees. Using my notes, compute the Jones matrix representation for a half-wave plate with the fast axis vertical. So I think I told you what a quarter-wave plate with the
Yes.
fast axis vertical was.
Which is that?
Right. And a half-wave plate is the product of the two quarter waves.
Yes.
And then the second part of the problem was
The second part you just
reoriented.
Let's go on. Yeah.
You just have a wave coming in 30 degrees to that, out from that axis, right?
So vertically polarized light is incident on a half-wave plate with its fast axis at 30 degrees. Okay, how are you going to do that?
Why don't you just move it this way and then have the...
That would be absolutely fine with me. It's much easier. Yeah, actually, you are right. You can take initial polarization this way and half-wave plate that way. In which case, you have to calculate the terms for the half-wave plate that way,
Yeah.
which is a mess. Or,
Yeah, that's what...
much easier.
Right, because the polarization of light is just defined in terms of force.
With respect to whatever device you put in there.
I do find the expression for the half-wave in terms of the sine and cosine with respect to the horizontal.
You found it. Yeah, I'm sure you. If you wiki anything, you'll. Yeah.
Well,
There's some
it ends up being really simple.
jerk in there who would already do that.
All you need to do it, to do it at any angle, all you need to do is multiply it on both sides by the rotation
Okay.
matrix and inverse rotation matrix.
Oh.
Yeah, no, the
Which-
question is it actually just this? I haven't attended the last class yet, but I attended one.
It depends on whether it's horizontal or vertical. He didn't
Okay.
care.
I don't know that I did any more polarization.
Oh, you're not?
Is it horizontal or is it they're vertical?
I might just say, here's what's finish up on this. Yes, that's simple.
It is vertical on the home run, I'm pretty sure.
Here, I'll tell you what a half-wave plate does.
It,
All right? If I have a half-wave plate vertical
I mean,
with my
yes.
incident light at this angle,
Yeah,
it flips it.
good. That's what I thought.
It's really cool.
I think half-wave plates are just wonderful. You have linearly polarized light. You want to shift the polarization. Let's say you want to rotate it by 90 degrees. Put a half-wave plate in at 45 degrees. It takes it, rotates it right around.
Oh.
Which is really hard to do any other way. You could put an infinite number of linear polarizers. That would work.
5 pi over 6
Wait, wouldn't you take that number? Well, you need.
There'd be loss in each one, which would be very bad.
Yeah.
It's,
Infinite number of
it's just asking what the units are.
It's the time average energy density.
What angle is it?
No, it's energy
No,
flux
doesn't.
per unit time.
Well, I mean, the series might help.
Let's say if I have a linear polarizer, oh, sorry, I start with light this way and I want to make it this way. Okay? I could put in a linear polarizer at 45 degrees, and then I get 1 over the square root of 2 for the amplitude. And then I put another linear polarizer this way, I get 1 over square root of 2. So I get 1/4 of the final intensity. 1/2 of the amplitude, 1/4 of the final intensity. If I put more linear polarizers in, it goes up. As long as there's no loss in the polarizer.
But to get halfway there, you'd have to take an infinite number of polarizers.
Yes.
So,
It's
so
much
Zeno's
easier to
optical
use a
paradox.
wave plate.
Zeno's optical paradox.
Yeah, I like that.
So it's just. So
Zeno's optical paradox.
Zeno's paradox is
Oh,
I can't walk over there because to get there I'd have to walk halfway, and then halfway from there again, and then halfway from there again an infinite number of times.
Yeah.
Because then you can't actually, you couldn't actually walk. That would take. But
But you know, time it takes you to walk through successive.
Yeah.
But yes.
And he didn't do the actual series sum.
Yeah, it means he didn't know how to do the series.
But it's amusing, right? Here, you can solve any one of them, but it seems that it can't all be solved at the same time.
I forgot.
So
Where's T sub n?
it was he did a really good job explaining how to get like the elliptical A from the A.
Hey, who? Ohanian has polarization.
No, he didn't get the from the elliptic. Yeah, he does.
Oh, okay.
To get the elliptically polarized, he did a really poor job explaining
Hex
it.
does a good job. Actually, Klein and Vertek does a better job.
I know. I'm well aware of this.
That's a good book.
Yeah.
Vertek was on the faculty.
Oh, yeah.
Why don't we use his book for something?
I think the problem is that Klein and Vertek is at just too high a level for a sophomore course. It's really a junior, senior course.
And just not wordy enough. Just not wordy enough.
No, they do things mathematically more.
I know. I was kidding.
Oh, okay. Yeah.
I mean, it's not
Hex
wordy
likes
enough.
writing words.
I
Lots
lost
of
my head.
words.
I don't know what happened to my head. I think it was at home. My mom like went to business somewhere.
Yeah, I have my hex with me. He was